Hello. Presentation dedicated to problem of clocks synchronization using network. It was prepared by Andrei Punko, it's me, using materials from Rod Stevens' book. Exact clock synchronization can be tricky due to inconsistent message transmission times that occur in shared network. The problem becomes much easier if server communicate directly without using a network. For example, if two computers are in the same room and you connect them with a wire, you can measure the wire's length, calculate the time it takes for a signal to travel across the wire, and then use it to synchronize the computer clocks. This works, but it's cumbersome and maybe not be possible between computers that are far apart. Fortunately, you can synchronize two servers' clocks fairly well by using a network if you assume that a network's message transmission time doesn't vary too much over a short period of time. Suppose you want server B to synchronize to the clock used by server A. Call the time according to server A the true time. Suppose E is the error between the two clocks, so TB equals to TA plus E. It's at any given time. Also suppose D, let it be delay required to send a message between two servers. Considered algorithm assumes that the delay remains roughly constant during the time it takes to pass the message back and forth. It also assumes that a message from A to B takes about the same amount of time as a message from B to A. The following steps describe the messages the server should exchange. First step, server A sends server B a message containing TA1, its current time according to server A. Server B receives the message and sends server A a reply containing TA1 and TB1, where TB1 is the current time according to server B. Third step, server A receives the reply and sends server B a new message containing TA1, TB1 and TA2, where TA2 the new current time according to server A. Now server B can perform some calculations to synchronize its clock with server A. As we said, suppose E is the error between two clocks, so TB equals to TA plus E at any given time. Also suppose D is the delay required to send a message between the two servers. When server B records time TB1, the initial message took time D to get from server A to server B, so first expression, TB1 equals TA1 plus E plus D. Similarly, when server A records time TA2, the reply took time D to get from server B to server A, so TA2 equals to TB1 minus E plus D. So we could subtract second equation from the first equation and get expression below on the screen. After solving this equation, which we saw on previous screen, we could get next result. E equals to this expression. After simplification, we got this expression. E equals TB1 minus, in brackets, TA1 plus TA2 divided by 2. So in result, now server B has an estimate of E, so it can adjust its clock accordingly. And need to remember that this algorithm assumes that the delay remains roughly constant during the time it takes to pass the messages back and forth. It also assumes that a message from A to B takes about the same amount of time as a message from B to A. That's it. Thanks. Bye.